Hello dear children, this is the 7th lecture on kinematics. In the previous classes, we discussed about distance, displacement and how they are related, speed, velocity, their types, acceleration. There also we discussed the types of acceleration. Mainly we concentrated on uniform acceleration and mostly retardation. And after that we discussed, we derived equations of motion by using the calculus method. But children, whatever the discussion which we had is what I can say, it's a horizontal motion. Means if your body is moving in a horizontal surface, okay, horizontally like this, horizontally. So how kinematic parameters are changed, how they are defined, and even we discussed the equations of motion for an object which is moving on horizontal surface. But one condition is there, children. What is that condition? Equations of motion are applicable for only an object which is moving with a uniform acceleration. So if any object is moving with a uniform acceleration only, we can apply equations of motion. Children, let us recall once again. What are the equations of motion which we derived, children? Yes, we derived V is equal to, first equation of motion is U plus AT. Second one is S is equal to ut plus half at square. Third equation of motion is V square minus U square is equal to 2as. And the special one, the distance travelled at nth second. What is that, children? Yes, S nth is equal to U plus A by 2 into 2n minus 1. Children, strictly these equations of motion are applicable only for an object which is moving with the uniform acceleration. That is what, acceleration must be constant, then only we can apply these equations of motion. That's fine. So in today's class, as I said that, yes, previously we had a discussion about the horizontal motion. In today's class, we will be talking about the vertical motion. Children, the best example for vertical motion is motion under the gravity. So today we will discuss, that is what actually I am trying to tell you. Today we are going to focus on motion under the gravity and how these equations of motion are modified for a motion under the gravity. Then you may get one doubt, sir, first of all, can we apply these equations of motion for whatever the topic, what we said is a motion under gravity? Can we apply or not? Yes, that is what I am telling you. So we will see first whether we will discuss whether can we apply or not. Once if we can conclude that yes, we can apply these equations of motion, then we will see how these equations of motion are modified for different situations under the what we can say motion under the gravity. Clear, children? Fine. And here one important, two important points to be noted actually. What is that? So 2 points we should understand very clearly, then the entire concept will become very easy to us. First, what is a free fall and what is the acceleration due to gravity? Children, these two terms are very important to have a better understanding about the motion under the gravity. And here 2 points, as I told you that here, So first one is free fall, children. So what is this free fall? See, in many situations you might have heard, so free fall, freely falling body, okay now. So first suppose, children, if I can take this marker, let us say an object, okay, if I leave this object, children, what is happening actually? Yes, it is falling. For suppose, let us say complete air resistance, everything is neglected. See, throughout a discussion, children, air resistance is neglected, then you leave it actually. So now initially, somebody is like forcing it to move? No, actually, okay. So the moment when it is left, so it is falling. But what is the reason for that? Yes, force of gravity. So because of force of gravity, objects are moving. Such objects are called freely falling objects. So what is a free fall, children? It is a phenomenon of falling of an objects under the action of gravity. Means during their journey, children, no other force should involve. Strictly force of gravity only should act. So I repeat, children, what is a free fall, children? The phenomenon of falling of an object under the action of force of gravity. Under the action of what, children? Force of gravity. So no other force should act. It is what actually free fall. Now come to the what is the acceleration due to gravity. So children, now this is very important to understand. Acceleration due to gravity. Acceleration. So first let us see what is acceleration, children. Yes, so the rate of change of velocity means whenever there is a change in the velocity with the time, children, we can say that some acceleration is produced. Now we are discussing about acceleration due to gravity. Acceleration due to gravity we will represent with the letter small g. Okay, children, let us take the case of free fall. Okay, here is an object. So it is left like this, freely it is falling. So initially its velocity is 0, right? The moment when it is left like this, okay. So what is happening? Initially its velocity is 0, but if you can see, children, do you think that the moment when you leave that object here, do you think that it will stay there only or it is falling? It is falling. Means what? Somebody is pulling. Some force is exerted on that body in a vertically downward direction, so that the body is moving down vertically downward direction. But if you can notice, children, as it approaches the ground, especially earth, children, as we are talking about the related to the earth, right? So its velocity keeps on increasing. So initially its velocity might be 0. So just before going to hit the ground, children, let us say it has velocity maximum, right? V. So there is a change in velocity. There is a change in velocity, right? So whenever there is a change in velocity, there will be some acceleration. Okay, let us take the case where body is thrown vertical upwards. Okay, now the body is thrown. So here it has some maximum velocity, but as it reaches upward direction, at a maximum height, let us say its final velocity will be 0. Okay, its final velocity will be 0, children. Means here initially it has a maximum velocity, but as it is moving vertically upward direction, children, its velocity keeps on decreasing. Here velocity is increasing, but here velocity is decreasing. Means what? In both cases velocity keeps on changing. So whenever velocity changes, children, there will be some acceleration produced. But the thing is that who is the reason for this change in velocity? Hence acceleration is produced, children. Yes, force of gravity. So because of force of gravity, there will be a change in the velocity. See, whether velocity is increasing or velocity is decreasing, that just keep aside. Is velocity changing or not? Yes, velocity is changing. Then who is the reason for that? Who is the reason for that? Force of gravity. That's what we are calling it, this acceleration, as a acceleration due to gravity. So children, the acceleration produced in a freely falling body due to the force of gravity is called acceleration due to gravity. And here this acceleration due to gravity is a vector quantity, very important. It's a vector quantity, and its direction is always vertically downwards, children. You may get a wonder, sir, why it is a vertical downwards, children? See, acceleration is always in the direction of force, right? So force of gravity, see, either in the first case or second case, in both cases, force of gravity is vertically downward direction. So hence we can say that, of course, acceleration is a vector quantity and its direction is always vertically downwards. Children, its SI units are meter per second square and the CGS units are centimeter per second square. In SI system, its value is 9.8 meter per second square. CGS system 980 centimeter per second square. Children, it is an average values, not exact values. Why I am saying average value? Why not exact value? Because acceleration due to gravity changes from place to place. We also studied that acceleration due to gravity is maximum at poles, minimum at equator. But whatever the values which we are taking for our calculation purpose, the average value. Children, in a feet cells, it's very important. It is a 32, very important, foot per second square. So this is very important. In some standard books, this value is given. Of course, generally we use 9.8 meter per second square, if not 980 centimeter per second square. But in some standard books, they will give you the acceleration due to gravity value in a foot actually. So 32 foot per second square. But mostly we will be using 9.8. But in some cases, for our mathematical, purpose, to make it more comfort, 9.8 we can take as a even 10 meter per second square also. Is it clear? Fine. But the thing is that, okay, acceleration due to gravity. Children, velocity is changing, velocity keeps on changing, so that there will be acceleration. Means what? Either this case or this case if we can take, it is not a uniform motion, children. It is not a uniform motion. It is a non-uniform motion. Means velocity keeps on changing. So motion under the gravity, very important point, very important. So motion under the gravity is a non-uniform motion. Non-uniform, which means what? Velocity is variable. Velocity is a variable. Velocity is not a constant. Of course, direction is not changing, but its magnitude changing, right? So motion under the gravity is a non-uniform motion, but the velocity changes, but the change in velocity is a uniform, children. The change in velocity is called what actually? Acceleration. So throughout the journey, children, either you can, means at a certain limited height, either you can take here, G value is 9.8 meter per second square only. So motion under the gravity is a non-uniform motion with uniform acceleration. Very important point, with a uniform acceleration, children. That's what we can apply. We can apply equations of motion for motion under the gravity. For motion under the gravity. Is the point clear, children? Fine. And there is a misconception. There is a small misconception. So many students think that motion under the gravity means just falling downward direction. No, there are three cases under motion under the gravity. So children, that is the first case, children. So here, body falling downwards. See, let me write here, body falling. So there is a small difference that you need to understand. Body falling. So when a body is falling, so its initial velocity is 0. Of course, velocity keeps on increasing. Second case, body thrown downwards only, children. Both cases downwards only. Try to understand. This is also falling downwards only. Downwards. So like this only it is falling. But here initial velocity is not 0. Then what makes the difference? Look at here. In the first case, just it is falling. Initial velocity is 0. In the second case, yes, it is thrown vertical like this. It is thrown like this. So as it is thrown like this, children, yes, there will be some initial velocity. There will be some initial velocity. Let me take a third case. Let me tell you the third case. Look at here. What is the third case? Body thrown vertically upwards. Means some velocity must be given. Some velocity, it should have some velocity, but vertically upward direction. So these three cases comes under motion under gravity only. But you may get one doubt, sir, in second case and third case we are applying force, right? Then how it comes under motion under the gravity? Children, just in the second case, third case, just we apply the force, but throughout the journey we are not applying the force. Try to understand. For suppose, if this body is there, if I am taking like this, yes, this won't come under motion under gravity. If I am just taking like this, it won't come under motion under gravity. Just I threw like this, okay. Oh, where is the marker? Okay. For second case, third case, just initially I applied force, but during its journey I am talking. During its journey, no other force should act other than gravitational force. No other force should act. Such a motion comes under motion under gravity. And here one more doubt many students will have. So whenever the bodies are moving under the action of gravity, why acceleration is taken as acceleration due to gravity? Because A is equal G we will take. A is equal G. For that reason is there. Look at it, children. So in the first case, so at any instant, children, at any instant if you can see, okay, body weight mg, that is the force according to Newton's second law of motion, okay na. So the net force is equal to weight, because other than the weight no other force acting, right, in these three cases. So here mg is equal to ma. So mg is equal to ma, right? Okay, mm cancel, so a is equal to g, right? In this case also, at any instant, the net force acting, acts in the weight only, right? So net force is ma, weight is mg, m cancel, so a is equal to g. Yes, even third case also, at any instant during its journey, children, the net force acting on the body is nothing but its weight only, that is ma is equal to mg, m cancel, so a is equal to g. So children, this is the reason why a is replaced with a g whenever an objects are moving under the action of gravity. So throughout our motion of the gravity, A is replaced with G. Whether plus G or minus G, we will discuss. But try to understand why A is replaced by G whenever the bodies are moving under the action of gravity. Means yes, this is a reason for that actually. Okay children, is it clear? Fine. So just copy this more. Just copy it. Children is yes. And children, here some conditions we have for the discussion of motion under the gravity. So under some special conditions only, what are the discussions which we are doing, all are applicable. Look at here. So here conditions, children, these are very important. So when we consider these points, then only we can apply our equation of motion for what we can say motion under the gravity. So the first one, children, what is the first condition? Anyone can guess? Yes. Air friction is neglected. Please note down. Air friction is neglected. Air friction is neglected. Okay. Fine. Second point, children. So here maximum height should be less than the R. R is what, children? Radius of Earth. Radius of Earth. Radius of Earth means whenever we are throwing a body vertical upward direction, make sure that the body should not go beyond the height which is equal to the radius of the earth. That's very important. Okay now? Fine. Third one. So whenever we are throwing a body's vertical upwards or downwards, children, make sure that the velocity should be less than the escape velocity. Escape velocity. Escape velocity. Children, these 3 points are very important. So whenever, what is the escape velocity, children? 11.2 km per second. So whenever I am throwing body vertical upwards, make sure that that should not go beyond that value, not even nearer to that also. Okay. And why we have taken this second condition, H max, why a maximum height reached by an object thrown vertical upward direction should be less than the radius of Earth? Because till certain height only G value remains constant. Beyond that, yes, with the altitude also G value changes. So in our discussion, throughout our discussion, G value must be constant. That is possible only when we consider these 3 points. Am I clear with this? Just note down. So when we consider these 3 equations of motion only, when these 3 equations only, our G is going to be a constant. Then only our discussion is going to valid for equations of motion. That's it. Okay, fine. Copy it. So children, motion under the gravity, actually we have 3 cases. The first case is, so body is just falling freely, so where velocity is 0. Okay. And the second case is the very important thing is that, so this is what actually falling freely. Okay now. Second one is ground to ground. Ground to ground. Ground to ground, which means what here? For example, this is a ground, children. So here, from here we are throwing a body. So it goes like this. It reaches maximum height. Again it comes back. Here is a ground to ground. Okay. Case 3 is height to a ground. Height to ground. Height to ground, which means what? Already we are at a certain height. Let us say we are from a building. We are standing in a building. From this above the building, body is thrown so that it goes, again it comes to ground. Children, these three comes under motion of the gravity only. But in many cases, as I told you, there is a misconception. What is that misconception? So motion of the gravity means people think that just falling like this, just a freely falling body. Of course, these 3 comes under freely falling bodies only. Motion of the gravity only. Because other than force of gravity, no other force will act, right? So there are 3 cases. But in today's class, purely we'll discuss in case 1 we will cover. Because again video going to be lengthy. So these 2 cases we'll try to discuss in a next session. Okay, fine. So first, children, let us take the case 1. Before that, we need to take some sign convention for this. Children, sign convention is a very important. So let us see the sign convention which we are going to take. Sign convention. Children, for example, if you want to throw body from the ground, it's okay, no problem. certain height, no problem. From the building, no problem. But the point of reference is very important. The point from where you are throwing, that you can take as a point of reference. That is very, very important. So children, for suppose let us say here is a ground, it is a ground, okay. From here I am throwing, okay. For me it is a origin, for me it is a reference point. So children, so vertically upward direction I can take as a positive, vertically downward direction we can take as a negative. So this what actually we apply for a throughout our discussion. For suppose children, we are throwing body vertically upward direction. So in the upward direction, velocity will be upward direction. So let us take a case where body is falling freely. Let us take this is a case, it is falling freely. Okay, na? So here initial velocity is 0, but no problem. But it has some velocity right after some time, yes. But velocity is downward direction, okay. Displacement also downward direction, okay. Acceleration due to gravity also downward direction. These three are downward direction. So these three are going to be negative. Because downward direction, right? Downward direction. For suppose if you are throwing body vertical upward direction we are throwing. So velocity is upward direction only. Displacement also upward direction only. And acceleration due to gravity still downward direction. Because acceleration is always in the direction of force, right? So force of gravity is vertically downward direction. That's for children. Acceleration due to gravity is always negative as per the sign convention rule. Whether you are whether freely falling body or throwing from the ground to ground, for example ground to ground or height to ground or ground to height, any case you can take more. G is always vertically downward direction. So as per the sign convention children, acceleration due to gravity is always negative. This is a very important point to be kept in your mind. So acceleration due to gravity is always negative. Why it is always negative? So as per the sign convention rule children, the physical quantities above the reference point are taken as a positive, below that we have taken as a negative. But the acceleration due to gravity is always negative. Am I clear? So if you can follow the really sign convention strictly, so G value is going to be negative. Fine? Okay. Now children, we will see how equations of motion are modified for a freely falling body in case 1, and let us see the related graphs also. Okay, look at it children. So let us write first equation of motion. First one is V is equal to U plus AT. Second one is S is equal to UT plus half AT square. So third one is V square minus U square is equal to 2AS. So children, it is first case. Okay, first case freely falling body, right? So we are taking for freely falling body. Case 1, what is it? Freely falling body means object is dropped from a height. Object is dropped from certain height, from certain height. Okay, so let us say this is a point, okay, now where it is dropped, so that it is coming like this, let us say. So okay, and just let us say the ground, height to ground. Okay, so this is how it is falling. Okay, so its initial velocity is 0 children. Let its final velocity be v, just before hitting the ground. Okay, let us say this height is, children, as it is a vertical height we can take as a h, horizontally we can take as a distance, right? But vertically we can take as a height. Okay, and if you can, okay, now this thing one. So acceleration due to gravity, yes, we should take downward direction, so it is a negative only. Downward direction is negative only. But children, did you notice displacement also downward direction only? So it is also going to be minus h. So here A also let us write as a minus g, and final velocity also, yes, downward direction minus v only. Children, as per the sign convention rule. Now let us take a first equation children. So throughout the journey, is there any change in acceleration? No, acceleration remains constant. Acceleration does not change with the time. So children, can you guess how the acceleration time graph will be? Acceleration time graph, yes. So for this, if you can see acceleration time graph, it is time. So acceleration is taken on y-axis. So it comes under here, right? A negative y-axis, children, because g is a 9.8 only. Yes, it is a 9.8 only meter per second square, but it is a negative, right? Minus g by vertically downward direction. So this is how actually you get a acceleration time graph for a object dropped from a certain height. Okay, fine. Let us take a first equation of motion. So first equation of motion, that is v is equal to u plus at, as a is 0 and v is minus. So minus v is equal to minus gt. So minus cancel. So v is equal to gt. Children, we know that g remains constant. So v is proportional to time, which means what? Velocity changes with time linearly. That's what, when you can just see a velocity time graph, children, this is a velocity time graph. Yes, you will get like this, straight line passing through the origin. So this is how actual velocity time graph which we will obtain for an object dropped from a certain height. Okay, fine. Now children, so let us take here s is equal to ut plus half at square. Okay, so s is what here? Height, that is a minus h. This is going to be 0 because initial plus 0 is equal to half. In the place of a, we should put a minus g. It is a t square. So both side minus is there, children, gets cancelled. So h is equal to half g t square. So this entire term is constant, right? So it is h is proportional to t square. That is displacement is, you also can say displacement is proportional to the square of the time. So that's what, if you can just make a graph. Children, have you copied this? Okay, fine. So if you can make a graph for a displacement time for a body dropped from a certain height, so time is a displacement, so we get a parabola like this. We get a parabola like this. Clear? Copied? Okay, fine. Let us say third equation of motion. Okay, here it is there. So this is v square minus 0 square is equal to what we can say, 2 minus g minus h. Anyhow, it is a v square. Minus v square is anyhow, okay, it can be a minus v square, but still it is a whole square, right? Will get cancelled. So v square is equal to minus to minus plus, it is 2gh. So v is equal to square root of 2gh. Children, 2gh. And children, if you can see here, so here is v is proportional to root h, right? Or we can say v is proportional to root s. But what kind of graph we are going to get? Look at it, because here velocity, it won't change in a linear manner, it will change in a non-linear manner. So if you can see, children, this is displacement, here is velocity. So you get a graph like this. You get a graph, okay, like this you will get. Okay, children. So this is how actually equations of motion are modified. Okay, now, and the related graphs. Okay, note down once. Note down. Okay. Copied. 3, 2, 1. Can I take out? Yes. So this here, children, even graphs also don't by hand. Why we are giving straight line and all these things, just based on the relation, how the particular two physical quantities are related. Based on that only we get related graphs. So don't by heart graphs. Okay, fine. So finally we got v is equal to gt, first equation of motion. Second one is s is equal to of gt square. Okay, fine. Third one is v is equal to square root of 2gh. Okay, this also let us take as a h only. Okay, and s nth is equal to, if you there also you can see g into 2n minus 1. Okay, fine. And here g by 2, sorry, g by 2 to 2n minus 1. So these are the equations of motion. But children, what is the time taken by a body to reach the ground? Time taken by a body. So of course body is dropped, but takes some time, right? That only we can call it as a time of flight. And you may get one doubt, so time of flight means going up or coming down. That is for ground to ground case. Here time of flight is what, children? The time in which the body will retain in air for some time is called time of flight actually. So for suppose here, okay, let us see time of flight. time of flight, okay. So here is the body is left freely and it is falling, coming. So here final velocity v. So this is hit the ground. So for this the total time taken is, let us say, time of flight, right? The total time taken. Okay. So let us take here second equation of motion. H is equal to half gt square. H is equal to half gt square, right? So H is equal to, this is half g. Here t is what? Time of flight, t square. So can we write t square is equal to 2h by g, of course. So t is equal to square root of 2h by g. 3 points we can conclude, children, here. The first point is that time of flight is proportional to the height, which means what? Here, if height is more, obviously the time taken to reach the ground also more. Okay. And the second point is that time of flight is inversely proportional to the square root of g. Here, if g is more, then time of flight is less. For suppose, children, on earth g value is 9.8, but whereas on moon surface it is 1.64. So where the time of flight will be more, children? On earth surface, if a body is dropped from let us say it's at the same height on earth surface or moon surface, but in which case time of flight is less, children? In which case? In the earth case, because in earth case g value is more, so time of flight will be less. Is it clear? Fine. And here one more important thing is that here time of flight does not depend on mass of an object. So these are the how can we call the time of flight, and this formula which we use to calculate the velocity attained, that is the final velocity attained by a body dropped from a certain height. V is equal to square root of 2gh and time of flight is equal to square root of 2h by g. Okay, just copy this related, at least one or two numericals will try to solve. Come on, copy it. Time of flight is equal to how much? Still, look at here, there are two numericals, very simple. In the first case, it is given that a body is dropped from a certain height, let us say h, and t is the time of flight. But it is given that, children, first half height to cover this h by 2 height, it takes t1 time. Second half time, that is h by 2, to cover this much height or a distance, it takes a t2. Then they are asking us to find the ratio of t1 and t2. Children, it's a very interesting question. It's very important also. Okay, look at it, children. So first we know that anyhow s is equal to ut plus half at square. Okay, we are doing the first numerical now. So vertically downward direction. Okay, s is equal to, we know that s is equal to minus h, u is equal to 0, a is equal to minus g, and t is equal to capital T. For a total, I am talking for total journey. So then this equation gets modified. H is equal to half g t square. Okay, equation 1. Can we write like this, children? The time of flight is equal to t1 plus t2. Yes, obviously. Equation 2. Now let us try to apply this first equation only for a first half. For a first half we are applying. For first half distance we are saying. So h is equal to how much? H by 2. Okay, is equal to 1 by 2 g t1 square. Let us say equation 3. Okay, substitute equation 1 in 3. In the place of h, can we write half gt square? Yes, we can write. Then it is half g t square by 2 is equal to half g t1 square. Children, half g cancel. Okay, now then this can be t1 square is equal to t square by 2. So here t1 is equal to t by root 2. So this is the time taken for a first half, but we want a second half, right? Yes, this t1 value you can substitute here. Okay, then what you will get? T is equal to, here t1 place we are substituting this, t by root 2 plus t2. So t2 is equal to children t minus t by root 2. So here t2 is equal to t, you can take a common, okay na, or else t by root 2 you can take as a common. So it will be root 2 minus 1. So this is t2. So why we have taken t by root 2 common? Because here t1 is t by root 2. Now they are asking us a ratio. So t1 is to t2. Anyhow t by root 2, 2 by root 2 is a common, right? So it will be 1 is to root 2 minus 1. So root 2 minus 1. So this is a ratio of the time taken. And you know, in some cases, okay, so half distance. In some cases they may give you first fourth distance, h by 4. Let me tell you. Have you copied this? Okay, here for suppose children, here let us say that, so this is h by 4 height, and next it is a h by 4 height, next it is a h by 4 height, next it is a h by 4 height. For this the time taken is t1, this is a t2, here is a t3, is a t4. The total height is h. From here the body is dropped. Now they will ask us to find the ratio of t1, t2, t3, t4. Children, apply the same concept. What you will get? You will get t1 is to t2 is to t3 is to t4 is equal to 1 is to root 2 minus root 1 actually, okay, is to root 3 minus root 2 is to root 4 minus root 3. So this is how you will get. Children, it's very important. Apply the same concept. Once you can find out t1, t2, it's very easy to us to find out t3, t4, t5, t6, what it may be. But the thing is that here it has to cover the same heights. Then only this concept is applicable. Okay, na? Just copy this. So as per the question, t1 is to t2 is 1 is to root 2 minus 1. So if they'll ask like this question, same question can be modified like this also. Here we got, this is a ratio. Okay, copy this. Copy. Done. Here is 3, 2, 1. Okay. Yes, children. Now, so here is a second numerical, if you can, second question if you can see, it is given that a body is dropped like the first case only, but it is given that to cover the second half distance is covered in a last 1 second. Then they are asking us to find the time of flight. Children, actually why I have taken the second question, you know, because this conclusion only is important for here actually. Okay, because already we know that for this the time taken we calculate, right? t2 how much we calculate, children? We got t by root 2 into root 2 minus 1. So this time is given for us as a 1 second. Now, so means t2 is given 1 second, and we know that t2 is equal to t by root 2 into root 2 minus 1. So here you can substitute 1. So then 1 is equal to t by root 2 into root 2 minus 1. Get this root 2 this side. So t into root 2 minus 1 is equal to root 2. So t is equal, that time of flight is equal to root 2 by root 2 minus 1. So this is a time of flight in a second case. Okay, children. So this is a case where a body is dropped from a certain height. So this is a case 1 under the motion of the gravity. More 2 cases which we have: ground to ground, height to ground. So other 2 cases we will cover in a next class. Thank you so much. All the very best.